compound interest is when you don't only earn interest on your original principal, what you invested, but you start earning interest on top of the interest that you earn. So let's say I invested $100 and it was compounding annually. So that's every year. It can compound monthly, weekly, annually. So this one's every year at a rate of 10%. So if I start with $100, in 1 year's time, I'm going to earn 10% interest. So 10% of $100 is $10. So in 1 year's time, I would have $110. After another year, though, I would then earn an extra 10% interest. But I'm not going to earn that just on the principal amount. I'm earning that on the previous year. So my interest then compounds. So 10% of what I would have divided by 10 is equal to $11. So it's going to be equal to $110 plus $11. After 2 years, I would have $121. Then let's go for a third year. 10% interest on the previous amount. So 10% of 121 is $12.10. So after 3 years, I would have 121 plus $12.10, which would be equal to $133.10. So you can see how I'm starting to earn slightly more interest every year because I'm compounding it, so earning interest on my previous amount. So each year I start with 100%. That is my previous year's amount of money of what I've got in the bank at the end of the year, and I'm adding a further 10% on the top. So each year my money increases by 110% or 10% increase on the original. That as a decimal is 1.1. So if I start with $100, after 1 year, it's going to be equal to $100 times by 1.1. That would give me my $110. After 2 years, it would be $100 times by 1.1 and then times by 1.1 again. After 3 years, it would be $100 times by 1.1 times by 1.1 times by 1.1. You could see I could actually simplify this by 1 year is equal to the $100 times by 1.1 to the power of 1. This one could be 100 times by 1.1 to the power of 2. And this one would be 100 times by 1.1 to the power of 3. So you can see I'm starting to get a little bit of a formula created. So if we let the letter N equal N years, so any number of years, whether that is 50, 100, might be 15 years, we would be doing 100, that's the principal amount, times by 1.1 to the power of N. So any number of years, so that number N could be 10 years, 11 years, you'd be able to work that straight out by putting a number in for N. So if we unpack this $100, that was equal to our principal, or the amount we started to invest with. The N represented the number of years. And if it's years, it's okay. It can stay the same and just as N if we're compounding yearly. In here, what we had together was 1. That 1 represented 100%. So the original amount that we're starting with for that year. The decimal that we added on was the interest rate. So we need to add on the interest rate as a decimal. What we have now pretty much discovered is the basic formula for compounding interest. You could work it out each year and how often it compounds, but there is a formula that works like this, and I'll show you on the next slide. Here is the compound interest formula, and it states that the amount, so that is going to be equal to the principal plus the interest on top, is equal to the principal, so the amount invested at the start, multiplied by, in brackets, 1, that represents 100% of the original principal. We learned that before. Adding the interest rate as a decimal, R, divided by the number of times the interest is compounded per year. So if it's annually, it'll be once. If it's monthly, you'd need to divide by, n would be 12. Then that needs to be put to the power of n, so n is still the number of times it's compounded per year, times by the time, so how many years do you have it invested for. Important to remember, BODMAS or BIDMAS when we are using this formula. So we need to do the brackets first, really important, before we do the order or the indices. Also important that we do division and multiplication before you do addition or subtraction. This problem here is the same one as the one on the first page. So we knew that after 3 years, our interest would be equal to, or our whole amount would be equal to $133.10. So if you use this formula correctly, it should be equal to $133.10. We know that our p-value, our principal, is equal to $100. We know that our rate is 10%. That as a decimal is equal to 0.1, dividing it by 100. Number of times the interest is compounded per year. It's compounded annually, so it's just once per year. And the time is over 3 years. So now we just need to put those values in the formula. So our amount is going to be equal to our principal, which is $100, multiplied by 1, representing 100% of that original principal, adding on the rate, so the rate is, as a decimal, 0.1, divided by the number of times it is compounded, so that is 1, all to the power of n times t. So n times t, I can already see n is 1, times by the time is 3. I'll just put that as 3 straight away. Really important now that we do the brackets first. So 100. In the brackets here, we must do the division first. So let's do 0.1 divided by 1. That's equal to 0.1. Then we can add that onto 1, giving us 1.1. All to the power of 3. You can see it now looks like exactly what we had on that first page. So on my calculator now, I am doing 1.1 to the power of 3. It's important that I do my indices or order first. So 1.1 to the power of 3, then, which is equal to 1.1, sorry, that's equal to, so it's going to be 100 times by 1.331. Then if I times it by that 100, which was my original principal, ends up with $133.10. So you can see that we ended up with the exact value that we got by doing it year by year previously. So that's how we use the formula. Let's see it in action again. How much would a $120,000 investment total after 15 years if it was compounded annually at a 7.5% rate per annum? That means per annum, per year. So in this case, let's find our values to put into the formula. Our principal, or our original amount, is $120,000. Our rate is equal to 7.5%, but we need that as a decimal. Divide it by 100, 0.075 is our rate. Our number of times it's compounded per year is once. It's compounded annually, so once per year. And the time is, in this case, 15 years. Let's now use the compound interest formula to work out how much we will total, or the amount that we'll have after that 15 years. So A is going to be equal to, the amount is going to be equal to the principal, which is 120,000, multiplied by 1 plus the rate as a decimal, 0.075, over the number of times it's compounded, which is 1, all to the power of n times t. So n times t, 15 times 1 to the power of 15. Working with the next step to try and solve, 120,000 multiplied by 0.075, the rate divided by 1 is staying the same. If we add that onto 1, we're going to end up with 1.075, all to the power of 15. So now, after doing our division first in the brackets, then our addition inside the brackets, now after doing the brackets first, we need to do the order or the power. So on my calculator, if I do 1.075 to the power of 15, I end up with an answer that is 2.9588, keeps going. So on the calculator, I'm just going to automatically now multiply that by 120,000, our original principal, and that will give me my answer, which is $355,065.28, rounded off correctly to 2 decimal places. How much interest would you pay on a credit card amount over a 2-year period of $7,600 at a rate of 15.2% compounded monthly? There are 2 parts to this question. In this case, we're not necessarily trying to find out the amount, the total amount to pay back. We only want to find the interest. But first, we're using the formula, we need to find out the amount. So, our principal is the starting balance of the credit card, $7,600. Our rate, or R, is 15.2%. So that as a decimal is 0.152, dividing that by 100. N, the number of times the interest is compounded per year. It's compounded monthly, so 12 months in a year, it's compounded 12 times per year. And our time period is 2 years. Now we can go and apply the compound interest formula. So our amount is going to be equal to the principal, $7,600, multiplied by 1 plus the rate, which is 0.152, divided by n, so the amount of times the interest is compounded per year, so divided by 12. That is then to the power of t times by n. So I've got t times by n. I'm just going to do 2 times by 12 straight away and just put that 24. We know there that we've done 2 times 12. So 7,600, and we know that we need to work with the brackets first. The division will be done first, so on my calculator. Be really careful to do this step by step. So I'm clearly going to do this part first, because we need to do the brackets, but first inside the brackets, division comes before addition and subtraction in BODMAS or BIDMAS. So 0.152 divided by 12 gives me 0.0126 recurring. I'm then going to add 1 to that, and in my brackets I'm going to have 1.012666 keeps going. I'm leaving that on my calculator screen because now what I want to do is I'm going to straight away do that to the power of 24. I'm going to put that to the 24th power, saving me having to type it in again. So that number to the power of 24 is equal to, on my calculator at the moment, it is 1.352 approximately. It does keep going, that's not rounded off. So what I'm going to do is that 7,600 times by what I now have, which is 1.35268, keeps going. So leaving that on my calculator screen, I'm multiplying that now by 7,600, so our original principal. The answer is $10,280, and rounding off correctly to 2 decimal places, 40 cents. It was 0.398, so rounding that off correctly to 2 decimal places, it's closest to 0.40 than 0.39. Remembering, however, that this was a 2-part question. We actually only wanted to find the interest you would pay, not the total amount, but the interest. So to find the interest, you would need to do the amount, take away the original principal, and that will give us the interest that you're paying. So the amount is $10,280.40. That's the total you'd need to repay to this credit card company. Take away the original principal of $7,600. That'll give you your interest. So do that on the calculator now. $10,280.40. Take away $7,600. The interest we pay is $2,680.40. The final example, Mr. Benwell purchased his car for $35,000. If it depreciates in value 18% every year, how much is its value now, knowing he purchased it 5 years ago? Important with this question is the value is going down, it is depreciating. So our principal, we are starting with $35,000. That's the amount I paid for my car. Because my car is depreciating in value, the rate is going to be a negative. So it is losing 18% or minus 18% of its value every year. So we could simply just take away 18% of its value every year and do that 5 times, and we would get to the answer. But we can use the compound interest formula. So that rate as a decimal is negative 0.18, dividing it by 100. We know that it depreciates every year, so the number of times the interest is compounded is once, so n is equal to 1, and the time, it is 5 years because I have had my car for 5 years. Let's now put that into the compound interest formula, and you'll be able to work out the value of my car after 5 years of depreciation. The principal of the starting amount was $35,000. 1 plus the rate, so the rate is negative 0.18 divided by 1, because it's only compounding every year. It uses value every year. Close the brackets. And then n times t. So you can see N times T in this case, I'm just going to put it as 5 straight away. So working with the brackets first. First inside the brackets, we need to do the division first. Negative 0.18 divided by 1 is going to stay the same. Anything divided by 1, stay the same. So what I'm going to be left with is 1 plus negative 0.18. Negative and a positive is going to be equal to 1 take away 0.18. So 1 take away 0.18 is equal to 0.82, all to the power of 5. Now I have to do the index next. So 35,000 is going to be multiplied by 0.82 to the power of 5 on the calculator is 0.3707 approximately, keeps going. So now I can just simply multiply what I had in the brackets by the $35,000. So I've got 0.3707, etc. on the calculator. I'm multiplying that now by $35,000. That now gives me $12,975.89. So after 5 years of having my car, it is depreciated and its value is now worth $12,975.89 because it depreciated 18% every year.